Hi, welcome to our first video on grade 12 trigonometry involving diagram and sketch-based questions in trig. We're going to look at past paper questions as this is a revision session. Looking at our first question, it says in a diagram PK1, so remember that represents x, the x value is k and the y value is 1, is a point in the second quad and is root 5 units, and you can see that in the diagram, which means that our radius here is root 5. From the point of origin, R is a point on the positive x-axis. An obtuse angle ROP is equal to theta. So if we look at our diagram, that is indicated for us. The first thing we want to do is, if we look at the diagram, we want to construct a right angle triangle. So I'm going to drop a line perpendicular to the x-axis, and that would produce a right angle triangle. And let's say, for understanding purposes, if we call this point T. So we have triangle OPT, which is a right angle triangle. Now we know that point P, the x value is k, so on the x-axis we will have k, and on the y-axis we have 1. So remember also that k is on the left, so we should end up with a negative value for k. So the first thing we're going to do is use the theorem of Pythagoras. And if we use Pythagoras, remember k squared is equal to the hypotenuse or the radius squared, which is root 5 all squared, minus 1 squared. And if we type that on our calculator, root 5 squared is 5 minus 1, that will give us 4. And the square root of 4, if we find k, which is the plus minus root 4, which will now give us plus minus 2, but we are choosing negative 2 because it's on the left side of the x-axis. Now, that gives us the first answer we're looking for, that k is equal to negative 2. And we can put that into our diagram to help us for the next question. So the next question is, without using a calculator, calculate the value of tan theta. Now we know that tan from definition is actually equal to y over x. And if we look at our diagram, the y value is 1. There we have it. And the x value which we found is negative 2. And we end up with negative half. The next question B says find cos of 180 plus theta. So remember, this is in our third quadrant. And cos in our third quadrant is actually negative. And you can quickly, just for information purposes, if you remember your cast diagram, and we have a mnemonic for that, all students take chocolate. So in our third quadrant, 180 plus, you'll notice only tan is positive, so cos would be negative. So we end up using reduction formula, minus cos theta. And remember, by definition, that cos is x over r. So we want to look for the x value, and if you look at the diagram, your x value is negative 2 over r, and your radius here is root 5. We're going to the third question, which seems to be a little bit more of a challenge, and it says find sine of theta plus 60 in the form of a plus b all over root 2. So we're going to use our compound angle formula to split off sine of theta plus 60. And if we use the compound angle formula for sine, you'll know that it's sine cos sine. So the angle we're using is theta, and we're using 60. And if it's a plus, then for S means your sign will stay the same, which will be a plus. So there's our expansion. And from here, we're going to substitute or use our calculator for special angles. Now we know using your calculator, cos 60 would give you half plus cos theta, and sine 60 from definition is actually equal to root 3 over 2. Now we can pick up sine theta from the diagram. So if we look at our diagram, and sine is y over r. So y value in the diagram is 1 over root 5, and we have half, and cos is y over r. And if we look at our cos value, which we found in the previous question, it's minus 2 over root 5, and then we still have our root 3 over 2. So now we're going to do a simple multiplication process. Numerator times numerator, 1 times 1 is 1. Root 5 times 2 is 2 root 5. And a negative 2 times root 3 will give us a negative 2 root 3. And the denominator's root 5 times 2 is 2 root 5. So you'll notice we have a common denominator of 2 root 5. And we bring the numerators down, 1 minus 2 root 3. And that is what they want in this form. You'll notice you have a plus b on the top all over a simplified surd that I have 2 root 5. But they want it as a simplified surd as root 20. So we can take it one step further and say that's 1 minus 2 root 3. And remember 2 is the root of 4. So we can rewrite 2 as root 4 times root 5, which is the same thing as saying 1 minus 2 root 3 and root 4 times root 5 is root 20. And we get the form that they wanted. Okay. There's one more question on this one. So I'm going to erase my board. And we now have 5.13. You can start reading that question. And if we look at 5.13, the question reads, use a calculator to determine the value of tan 2 theta minus 40, correct to 1 decimal places. Now, our diagram is referenced with theta. So we're going to use that as our starting point. Now, if you look at A, we found out that tan theta was equal to negative half. So that will allow us to find theta. So you're going to use your calculator. And remember, if it's negative, it will be an obtuse angle we're looking for, 1 minus. And you're going to use your calculator and say shift tan half. And if you do shift tan half, you should get 26.57. And if we work that out, we get 153.43. Now, so we know the value of theta. All we're going to do now is substitute. Tan, according to this question, we want 2 theta. So we're going to put 2 into 153.43 and subtract the 40. And that will give us, using your calculator, tan, we're going to work out the brackets, 2 times 153.43, and then subtract 40. That will give us, sorry, my PowerPoint skipped, that will give us 266.87. And then you're going to take your calculator out and find the tan of 266.87. And using your calculator, you should get 18.3. And that is our answer for that. Okay, we're looking at a second question which says, given that sine alpha is equal to minus 4 over 5, and alpha is between 90 and 270, and the question is, without using a calculator, determine the value of each of the following. So if we look at our diagram, I'm going to construct firstly our right angle triangle, and they are telling us that the x value here is -3, which we're going to put in. They also tell us the y value is -4, and using Pythagoras we can find the radius, which is 5. So we have used Pythagoras to find that. The first question is sine of negative alpha. Now that is a negative angle, which is in the 4th quadrant, or we can use 360 minus alpha, and that means that sine of negative alpha is negative sine alpha. Now if that is negative sine alpha, they already gave us the value of sine alpha. We can just replace that and say negative of -4/5, and that gives us what we're looking for, 4/5. The next question is to find cos of alpha, which is x/r by definition, and we would have found our 5 using Pythagoras, and the x value is -3/5. Coming to the last one, we will use compound angle formula again to split that up. Sine, cos, sine. The angle we're working with is the alpha and 45. And remember, if it's negative, your sign stays the same. It will stay as a negative. All right, and if we look at our diagram, we have found sine alpha. Actually, it was given on the top. So we can replace sine alpha with -4/5. Cos 45 is a special angle, and that is 1/√2. Minus cos alpha we also found in a step above, which is -3/5. And sine 40 is a special angle, which is 1/√2. And now we're going to use multiplication. Numerator times numerator. 4 times 1 is 4/5√2. And then we got a negative times a negative will give us a positive. 3 times 1 is 3/5√2. And put them together, common denominator of 5/√2. We're going to take our -4 plus 3, and that will give us a -1/5√2. Okay, our next question is a little bit of a challenge, so let's go through it slowly. It says in the diagram we have a point T, which is xp. So remember, the p value actually represents y, which is in the 3rd quadrant, and it is given that sine alpha is actually equal to -p over root of, and remember sine means y/r. So I'm going to quickly construct that triangle just to see what is happening here. So we know that our y value according to this is p. So let's put it down. X we don't know, we're going to leave it as x. Now from here, if you look at it, your radius is actually given, which is the root of 1 plus p squared. So the first question is to show that x is -1. And because I have all the sides in my triangle, I can form an equation using Pythagoras. So remember, Pythagoras is x squared plus y squared is equal to r squared. So there's our Pythagoras we're using. And if I use that, my x value, if you look at the diagram, is x. So we now have your x to stay as x. Your y value, if we look at our diagram, our y value is p. So that will become p squared, which is actually equal to r squared. And if we look at the diagram, our r value is 1 plus p squared, and we're going to square that. So we've just done a substitution. And if we work this out, we're going to get x squared plus p squared is actually equal to, if you square roots, they will cancel off, and we're left with 1 plus p squared. So if we take our p squares p squared goes on the other side, becomes a negative p squared, and that will now cancel off, and we're left with 1. And then x is actually equal to the square root of 1, which is plus or minus, but we're going to choose negative 1 because x is on the left-hand side. And we get exactly what they want. Our next question tells us to write cos of 180 plus alpha in terms of p. So if we look at cos of 180 plus alpha, we are looking into the third quadrant, and in the third quadrant cos is negative, so we're going to use reduction formula and we come out with negative cos alpha. And remember, from our diagram, cos is x, which we found to be negative 1, so we're going to use negative 1 over r, and we've worked out our r value to be the root of 1 plus p squared. So a negative and negative will give you a positive, and we get 1 over 1 plus p squared. And that is our answer for 5.32. We're going to our last question, and it says in the last question, if we're looking at that, and I just want to change my color, it wants us to show that cos 2 alpha, so that's our starting point, cos 2 alpha. And we're going to write it out in a form 1 minus p squared over 1 plus p squared. And I'm sure lots of you are saying or screaming, this is a double angle. So if it is a double angle, we can use the double angle formula. And we have lots of choices, okay? And I'm going to take the easiest one. The expansion here, so that we don't have two trig ratios, will be 2 cos squared alpha minus 1. Now we're going to substitute. If you look at our question, all right, we found minus cos alpha. Okay, if we're not confident, remember cos is x over r. And if you look at your diagram, your x value is negative 1, and your r value is 1 plus p squared, the root of 1 plus p squared, minus 1. Don't forget your square sign. So if we square that, it will make negative 1 positive, and then we're going to multiply the 2 in. You'll get 2, and if you square square root, that should cancel off, and we're left with 1 plus p squared, minus 1. And if you look at what we want to do, we're not there as yet, so we're going to write the 1 as a fraction, and then we're going to find an LCD, and your LCD here would be 1 plus p squared. So we're going to multiply this by 1 plus p squared. And then we get a common denominator of 1 plus p squared, and we get on the top 2, and there's a negative 1 being multiplied into a 1 plus p squared, as you can see, which will change our signs and end up with minus 1 using distributive law, minus p squared. And then we know that 2 minus 1 is 1 minus p squared all over 1 plus p squared. And that is what the question wants us to find.